All right, we're starting chapter 6, rational numbers, and section 6.1 is an introduction to the set of rational numbers. Whoops. All right. I'm going to let you read the Common Core standards, but grade 3 is when students are starting to understand what fractions are. By grade 4, they should understand fractions as a number on the number line. So we're going to look at that in this section. A unit fraction is a fraction with a 1 in the numerator. So something like 1 over 4 is a unit fraction. In general, the set of rational numbers is denoted with a bold-faced Q, and it's the set of fractions, right? A over B, where A and B are integers, and of course our denominator can't be 0. We call the top of the fraction a numerator, and the bottom of the fraction is our denominator. Okay, so rational numbers show up in all sorts of places. If we're looking at division problems, so now students can solve problems like 2x equals 3. That's something they couldn't solve until they learned about rational numbers. So 2x equals 3, we can divide now by 2, and so we get an answer of 3/2. They can use rational numbers when they're talking about partitions or parts of a whole. So for example, Joe received half of Mary's salary each month for alimony, and then you could tell them what Mary's salary is and ask how much Joe received each month. You could use rational numbers when you're talking about ratios, like ratios of Republicans to Democrats in the Senate. And of course, rational numbers come up in all sorts of probability problems. So the example here is tossing a coin. We want to get kids comfortable with picturing rational numbers, and so here are several ways that we can visualize rational numbers. So the first example here is an area model. So our whole is the entire square, and it's divided here into 3 equal parts, and only one of those parts is shaded. So this represents 1/3, right? 1 out of 3 equal sized parts. On the number line, I'm going to separate the interval from 0 to 1 into equal sized parts. Again, I've got 3 parts here, right? 1, 2, 3. And I've shaded 2 of those parts, so this represents 2/3. This notch here is 1/3, and then 1, of course, is 3/3. In the set model, it will help if you put a big circle around your set here. But here, my set is the set of all 5 of these pieces, and I've shaded 3 out of the 5 pieces. So this represents the fraction 3/5. All 3 of these are ways that you can represent fractions with your students, and you want to be comfortable with all of these representations. All right, so this is what we were looking at on the last slide. To understand what A over B means, using the parts to whole model, we have to know, first of all, what the whole being considered is, how many equal sized parts we've divided the whole into, and the number of parts of the whole that are selected. And that's exactly what we did on the last slide with each of those examples. We're going to say a fraction is proper if it's written as A over B, where the absolute value of A is less than the absolute value of B. And obviously, absolute value is always bigger than 0. Okay, so the top, the numerator, is less in absolute value than the denominator. So for example, 5/8 is a proper fraction. -2/3 is a proper fraction. In both cases, if you look at the absolute value of the numerator, it's less than the absolute value of the denominator. All right, if a fraction isn't proper, it's improper. And so in that case, the numerator here is going to be the bigger number. Okay, so an improper fraction always satisfies that if I take the absolute value of A over B, I'm going to get something that's bigger than or equal to 1. So for example, if I flip both of those fractions that I had in the example above, that gives me improper fractions. So 8 is bigger than 5, so 8/5 is improper. And 3 is bigger than 2, so -3/2 is improper. Okay, so grade 3 here, students need to represent a fraction a over b on a number line by marking off a lengths of 1 over b from 0. Okay, so what I've drawn here for you is a number line from -2 to 2, and we've got some equally spaced tick marks, and our goal is to determine what the numbers are that are represented. Now, I know you have the answers in your slide, but let's talk through how we would find these just to make sure we all are on the same page. All right, so if I look at starting from 0 and I count how many steps it takes to get to 2, I've got 1, 2, 3, 4, 5, 6, 7, 8. So it's broken into 8 equal-sized pieces. I know that halfway between 0 and 2 is 1. So that means if I go 4 spaces over, I should be at the number 1 here. And now if I look from 0 to 1, I'm broken into 4 equal-sized pieces. And so then I know that this must be 1/4, this is 2/4, and so this red dot here must be 3/4. Now you can use the same sort of reasoning to find the other numbers. So if I look to the left of 0, this first red dot here is 1 tick mark away, and we've said that we've broken it into 4 pieces between 0 and 1. So this is going to be -1/4. If I go 4 steps away, I'm at -1. Now, what about the red dots that we've got on either side of -1 and 1? Let's look over here on the right side first, this dot right before 2. Well, 1 we could think of as 4/4, and so we just keep counting, right? So this is 5/4, 6/4, and so 7/4 is here. And of course 2 is 8/4. And same idea to the left. So I've got -1 is -4/4. And so I've got -5/4. This is going to be -6/4. And this is -7/4. Now, of course, -6/4 reduces, and we're going to talk about what that means in just a bit. All right.